Good evening to all. First of all, it's just a brief discussion. I'm just a small part of as a sanctional engineering consultant private limited. Those people who came yesterday know well that in the area of heat transfer, mass transfer, equipment, and designing, fabrication, erection, commissioning, and process designing, process innovation, such type of work we are doing. Today, we are presenting our patented process, a process of black liquor conditioning by 95% CE and raw material washing by green liquor and acid neutralization. Actually, it is non-process element leaching out before before the digestion. Help our company too much, so it's my duty to thank them. These are the various type of raw material being used in the paper industry. This is the bagasse. So how we can judge which raw material is good and which raw material is bad for the processing of the pulp? So if you see lesser the ash content, better is the raw material and better the black liquor. But just before this presentation, we have discussed that choosing a raw material is a strategic decision. We cannot think that we cannot bring here softwood raw material if we, as we all know that softwood raw materials, black liquor is best and good, and solid concentration is possible up to 85%. We can enjoy high steam generation from that. So we have to make best out of the worst. If you see the wood chips, ash content is only 0.6, means 6 gram of the ash content per kg of the raw material. If you see the bagasse, it has ash content 5 to 6.5%, means 65 gram per kg is the ash content. And if you see wheat straw contains ash content 7 to 8.5%, means 85 gram per kg is the ash content. Out of this 80, if it is 8.5%, then 85. Out of this ash content, 60% is the silica only. We have to reduce the silica content. We have to reduce this calcium content. We have to reduce magnesium, alumina, and this is our duty to reduce it. Because the major concern is to get the high steam generation from this agri-waste raw material also. And these dead loads and non-process elements accumulate in such a way that there are some mills, they are not able to even generate black liquor solid concentration even more than 50%. There are other industries, those are achieving solid concentration up to 68%, but they are mixing the wood liquor also in that. Objective of this whole presentation, whole work and patent is that we should reduce these non-process element and get the solid concentration from the agri raw material to more than 75% alone without mixing any wood liquor. It is their helplessness to mix the wood liquor because alone dead load has accumulated in such a way that the black liquor doesn't get fired in recovery boiler properly. If you see the recovery boiler operation for firing the wood liquor, they are maintaining primary air pressure 50 to 60 mm WC. But when we are using agro raw material pressure, we are not only increasing the firing temperature, we are also increasing the air pressure, which is leading to more carryover. And if there is salt like NaCl, KCl, the carryover will be more. If the carryover will be more, it will stick to the superheater and other heat transfer areas. Ultimately, will plug the passes So the draft will be in the right side. Ultimately, he has to save the boiler, operator and in charge. He will increase the ID fan and steam generation will reduce up to 2.7 ton per metric ton. Otherwise, if you see the GCV of this raw material, as I have said, if you see this bagasse as such, GCV is near about 4,000 to 4,300, and for wheat side it is 4,000, and for wood chips it is approximately 5,000. And if you see the worst raw material is, we say, it is rice straw. But if you see ash content is 50%, accept silica, see the silica level, it is 93 gram per kg. If we are able to reduce the silica, I think the best raw material is rice straw, and it is cheaply available. India is agri-based country, our economy is mainly dependent on agriculture. If we use these straw bales, we can reduce major concern of the country. And this raw material is easily and cheaply available. By our process, though we have not treated the rice straw, we have treated the wheat straw. I will show the result and the testimonial, how much result we have achieved. These are various type of WBL. Bagasse TT, it is approximately 25 to 27 gram per liter. And in case of the wood, it is a 50. RA, this is usually in the agro-based raw material is mandatory to keep the residual active alkali slightly high. And even wood liquor also we are maintaining slightly high residual active alkali so that high solid concentration is possible from the evaporator. And fiber content as low is possible is the goal. This is the Na2CO3 by Na2SO4 ratio. This ratio should be as less as possible if you want to achieve higher solid concentration from the evaporator. If you want to achieve higher solid concentration from the evaporator. This is the solid concentration. This is the organic and inorganic. This is the black liquor GCV, not the raw material GCV. If you see, usually if you are starting the wheat raw material, initially you will get GCV in this range. But after 5 or 6 years, this GCV will drop to 2,800 kilocalorie per kg. And sometimes we are surprised why this GCV has dropped, because it is nothing but due to the accumulation of the dead load and non-processed element. Black liquor is a mixture of organic and inorganic. There are some inorganic which is desired, which is contributing to Na2O, but there are other inorganic which is not desired, like silica, calcium carbonate, and so many, aluminium and other ions. Those are contributing. These are the undesired inorganic. These are not contributing either in the green liquor generation or the steam generation, and must be purged out before it enters the cycle. And if you are thinking of to leach out the chloride from the ESP ash or other technique which is available, we think that it is not that much sustainable, because our main objective is to get high steam generation from the recovery boiler side. Though it is not the subject to include so much, but it is so important also for economically viability of this whole topic. So if you see, most of the mill generating steam generation, agro-based especially, 30% of the steam generation is contributed from the recovery boiler. On as I am talking of the average paper mill. Those are running in very good condition, like Star also. Star also contributing 50% steam generation from the recovery boiler. Remaining is the power outside. So those are the benchmark. Though internationally if you see globally, people are generating 85% of the steam generation from the recovery boiler side. So we have this project, if you see, A process of black liquor, a good black liquor from the worst raw material. This is the graphical representation. What is the impact of, or we can say, what is the good black liquor or bad black liquor? If you have Na2CO3 and Na2SO4 ratio, means if you are taking out a solid concentration of 55%, the Na2SO4 ratio, I have to it is some tilted there. If your solid concentration from the evaporator is 50 to 55%, ratio can be up to 2.5 is good, no issue. But if you are aiming solid concentration up to 75% or more, then this ratio must range in this region, Na2CO3 to Na2SO4. This is the Burkett region. Burkett is easy to wash out with the hot water or weak black liquor. If you move, if you are still maintaining the cast sizing efficiency 78% or 80%, the ratio, your range will be this one, dicarbonate. This dicarbonate range is one which is very hard scale, and this scale can be removed only by hydrojetting. So, if first condition is that our ratio should be maximum 0.9 for a good black liquor condition, so that it is in the range of this disulfide range. So, what I am saying, 95% cast sizing efficiency means what? Most of the people think that if we will increase the cast sizing efficiency up to the 95%, is very obvious question comes in the mind that the free lime will also increase. So, in first stage, we are reacting the green liquor with lime till this 78% cast sizing efficiency. White liquor taken out from the CD filter or the clarifier is again reacted with the lime up to the 95% cast sizing efficiency. And this cast sizing reactions white liquor is taken out, and underflow still have free lime. This is brought back into the slacker number 1 to utilize the free lime. So in this process, if you see, free lime is not carrying out toward the mud filter. Free lime is neutralized in the slacker 1. So even white liquor have, and usually if you see, people used to say it is reversible reaction, and it will be converted back into the carbonate. It is not such the case. If you are removing the continuously the reactants, it won't reverse. It will only reverse when you keep it held. This is the two-stage cast sizing efficiencies. NOH is 85, Na2S is 30, Na2CS is 23, Na2SO4 is 3 to 4 GPL. Actually, it is in the white liquor remaining. If the reduction is only 90% or 90 to 92%, being the practical, most of the industries have the reduction efficiency of this much. So TTA is 115, TT is 138, active alkali is this much. Cast sizing efficiency is 79%, and the ratio, what we were talking about, it was 5.75 Na2CO3 by Na2SO4 range. In the black liquor, what we recommend, and if Na2SO4 ratio is more, then it is good rather than of carbonate. After 95% cast sizing efficiency, if you see, the white liquor generation will have Na2CO3 by Na2SO4 ratio is 0.93. This is what I was saying that if you add, you see there 6.5% means 65 gram of the ash, and from the SiO2 point of view, you will see this is the worst raw material, rice straw. Second worst is wheat straw, and the last is bagasse. If you see the wood chips, it has only 1.4. from the Al2 point of view. Bagasse has the highest amount of Al2O3. The next is wheat straw, and the least is rice straw. Means rice straw is better here in this case. If you see the bagasse, it is containing 2.8 gram per kg of the bagasse on dry basis, and wheat straw contains 5 gram per kg of raw material. Here is the wood chips. Here MgO3 highest in the bagasse, then wheat straw, and least in the rice straw. I think this gives a better clarity. Washing at the 5% consistency. It needs water 19 liter per kg of the raw material. Ultimate crux is that this is our process. Raw material is brought in the first separator. It has a strainer and agitation system, because as Dr. Dixit has told, the calcium and the magnesium has solubility in even 10-degree temperature. Ambient temperature is 30 to 35 degree, though it is a counter-current washing, but the temperature will be approximately 65 degree here. So most of the KCl, NaCl and grits, sometimes grit sands usually come in with the raw material, it is removed here. The water comes here, raw material moves here, and water is taken here. It is counter-current washing. So in the second stage, we have used weak green liquor. You can say drag wash or soda ash, DAX. We can add. We have to maintain 11 pH, 10 to 11 pH, so as to react with all the calcium, magnesium ions, as well as chloride in the form of calcium chloride and magnesium chloride. Those are the reactions are missing here. But actually chloride are in the form of calcium chloride, magnesium chloride. There are some free chloride also. So after the reaction, after the reaction, calcium carbonate is get separated and it is get removed here before entering the digester. Because ultimately, if you want to remove the calcium content here, it will go into the digester. After the digester, in the digestion, it will react with the free Na2CO3 which is coming in the white liquor. It will precipitate out definitely. Better it is to remove in the washing stage so that it won't build up in the system. Here it is the results. It is for wheat straw and the CBTVRA reports. Moisture was 87, ash content was 2.98%. But we have in this another result from the Avanta, we have achieved ash content up to 1.3%. Means from 8% ash, wheat straw is ash content reduced to 1.38%. I will show the testimonial there also. If someone wants, I will share with those. If you see, calcium content is 0.005%. Almost 98% of the calcium content is removed here. And you see the silica content. It is 0.99%. Means 1% you can take it. Usually in wheat straw, silica is approximately 3 to 4%. It varies, but statistics will remain the same. Now let us talk about what is the meaning of that. Why it is so important. Suppose if you are firing 300 ton solid in your recovery boiler, you are firing approximately 42 to 45 ton dead load. This 45 ton dead load means approximately, if you see, due to this dead load, solids per ton of pulp generation is more if you are not removing that. Solid per ton of pulp in some mills is approximately 1.4 ton per pulp. If you remove this dead load or reduce the dead load, this solid generation will reduce to 1.1 ton per ton of pulp. Means there is a leeway to increase the pulp production also. And these dead load, 50 ton dead load, doesn't have any contribution in green liquor generation, neither in steam generation or green liquor generation. These are just dead load. If you remove the dead load, GCV of the wheat straw liquor itself will increase to 3,200 kilocalorie per kg, which means it is better than wood liquor. See the data. This is the treated raw material interpretation. If you see, 77 gram is the COC, SiO2, 2435. In terms of SiO2 per day, if you talk, silica generation is 0.73 ton per day, and COE is 0.023 ton per day. Means treated raw material have this much dead load. 1.5 I have calculated, but our team has calculated. Take it 5. I am multiplying the 3 times. Even then it is better than. Even then it is better than other raw material, because treated raw material itself is good. Except silica, calcium, magnesium, if these parts are removed, then raw material is better, because it is consuming less white liquor, it is consuming less active alkali charge, it is producing less solid. We are able to produce more pulp. Ultimately, what is the worst, we have to make it the best. Because raw materials scarcity already is there, and within 1 or 2 years there will be approximately, I think there will be born on the coal consumption totally, and we have to produce more and more steam generation from this renewable or this type of raw material. We have to think vigorously toward it. We are in the patent, we are NDA with one of the Punjab-based agro mill, but we cannot disclose the name of the company because we are in NDA with those. Those people really want to have more discussion and their impact on operation may come forward to us, and we will disclose all the technology. And in this process, water, usually if you see the wet washing water, if you are we are operating wet washing of 500 TPD wheat straw, approximately 80 MQ per hour water is going to the ETP. In our system, because we are using Na2CO3 and H2SO4 for neutralization, water definitely have some CUD as well as chemical also. But in our system, water going to the ETP will be 0. There won't go any water to the ETP. This water will be regenerated and it will be reused. And all the salts will be removed separately. This was the whole subject. I think you may have liked it. Impact. Black liquor solid concentration is possible up to 75% easily after the treatment, provided proper RAA and fiber content in WBL. Evaporator jamming frequency will be reduced. Downtime of evaporator will reduce. Silica in the raw material reduced to 1%, even less than 3.5%, means most of the agro paper mill which are thinking to run the lime kiln, now they can run the lime kiln, because in 3.5% silica content in the lime mud, you can achieve 80% purity of the lime easily. But I am quite agree with Dixit ji, because it is just the boundary line. If you reduce the furnace oil to get the more purity instead of increasing it will decrease, because the silica will bind with the calcium oxide and form calcium silicate, and you will find in your test result that we are giving more fuel but purity is getting down. So lesser the silica, better purity of the lime. I am quite in accordance with Mr. Dixit. So then clinker formation in the lime kiln will reduce. Makeup limestone requirement will also be reduced. Why? Because as the Dixit is said, if we have 4 to 5% silica and we want to maintain 1% silica in the raw material mix, how much material we have to dispose of to maintain the silica? Approximately 98% of the lime mud you have to purge out. If there is 5% silica, I am talking about, and we have to bring down it to 1% in the raw material mix. Steam generation from the recovery boiler will become as good as to 3.5 ton per day, which means this much savings. Spout jamming, airport jamming frequency will reduce. By reducing that load, there is a leeway to increase the pulp production. There are still a lot of benefits. If we discuss, the whole day will complete, but its benefit cannot be completely discussed, because if there won't be calcium content and silica content, there won't be erosion. If silica is reduced, there won't be erosion in the paper machine side also. Wear tear will be less, and if there is lesser calcium magnesium content, screen jamming in the brown stock washes and other bleaching area will reduce greatly. There's a lot of points.